A very good morning, students. A very good morning, students. Let's begin with today's topic. But before going to the main topic, I would just want to tell you that we have just studied the chapter number third, and in the chapter number third, we have understood all the history, how the periodic table is finally formed. है ना? So this was the table, how we have classified our elements in the form of a tabular. Okay, so this was something which we have studied in our last class. That is very easy and very basic class previously, basically. And I'm saying this statement again and again that chapter third is very short and very simple chapter. Okay, in this we have to just memorize the periodic table. That means we need to memorize in our periodic table what are the maximum information. So periodic table हमें कितनी maximum information provide करा सकता है about anything that we're going to begin. Okay, so I think you're ready, and let's start with today's topic. So basically today I'm just going to elaborate you with the whole periodic table. कुछ नया नहीं है. This is all the periodic table, but it contains so many small lot of informations that would deliver you to the higher extent of level. Okay, so we are going to basically study a topic that is periodic table, and in this we would consider which are the maximum advantage we can get over. All right, so should I start? Okay, now first of all, I have already told you that our elements are almost 118 or 120. I have told almost 118 to 120 elements, but the point is all these elements have not been classified, have not been categorized into our table. And what is the reason behind that? The reason behind that is these many of them are radioactive elements. They are the man-made. So हमें ही उसके बारे में information नहीं पता है. So how can we put them into our periodic table, na? So this is the first point. Okay. Secondly, I'm going to elaborate our periodic type of electronic configuration. In our last class, मैंने आपको थोड़ा सा idea दिया था that electronic configuration is something on the basis of which our complete periodic table has been formed. All right. So today, on the basis of electronic configuration, what are the different kind of atoms? What are the different kind of elements that are arranged? That is our main topic of study. All right. So the first point is quite obviously the electronic configuration. We know that our modern periodic table that is totally based on atomic number rather than the mass number. You know that we have took the atomic number as usual as compared to the mass number. है ना? So the first point is on the basis of atomic number, we have arranged them in our increasing order. Now, the most importantly, I would like to say that if I start with the different type of periods and groups, see बच्चे हमारी जो टेबल है वो बहुत लंबा चौड़ा सिस्टम है, बहुत ज्यादा ऑर्गेनाइज्ड वे में हमने these elements को याद रखना बहुत मुश्किल है ना? So that's why we have arranged them in the form of period as well as group. मैं दोबारा रिपीट कर रही हूँ, on the basis of period as well as group. अब पॉइंट ये है what is known as period and what is known as group. जो हमारी horizontal position है that is known to be period. The horizontal position is known to be period, whereas ये जो vertical है these are known to be group. These are known to be group. Okay. So basically अगर मैं period की बात करूं तो 1, 2, 3, 4, 5 and 6 हमारे पास in actual सिर्फ 6 periods हैं. Okay. We have total 6 periods in which we have arranged our all 118 elements. बन रही है बात? Same as it is if I would like to go on with the groups. जो हमारे groups हैं that are 1, 2, 3, 4, 5, 6, 7, 8. That means हमारे पास total 8 groups हैं. Now the question arises, हमने इसको क्यों नहीं ग्रुप में इंक्लूड किया? हम डायरेक्ट से वहां पे क्यों जंप कर गए? उसके पीछे भी एक रीजन है that we will study within the same class. Okay, so हमने अभी तक सिर्फ इतना क्लियर किया है that we have periods and groups on the basis of atomic number, but the point is हमने उनको इस वे में अरेंज किया है कि each period or each group has somewhat similar physical as well as chemical property. Okay, यानी हमारे जो periods और जो groups हैं हर एक का जो मैटर है, हर एक के जो अंदर एलिमेंट्स प्रेजेंट है they all are somewhat dependent on the same kind of physical or chemical properties. बन रही है बात? Okay, so now let's start with electronic configuration. First of all, we know very well that हमारा जो first group है उसके अंदर हम start करते हैं with the hydrogen. That is, hydrogen must be contained with the atomic number 1. So this is somewhat known as first group, hydrogen. Okay, but मैं hydrogen को अलग से mention कर रही हूँ. There would be a reason, I would see. Now the first point is hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. ये जितने भी हमारे elements हैं, they all S1, 2s1, 3s1 electronic configuration. That means in their outer orbit, in their outer shell, there is one electron present. All right. और इसीलिए हम इनको क्या बोलते हैं? The electronic configuration over here is ns1. Same as it is if I'm going to go on with the second period, it has ns2. Okay. That means 1s2, 2s2, 3s2, 4s2, 5s2 and 6s2. Okay. Now this is somewhat known to be about our s block elements. Why do we call them s block elements? मैंने आपको थोड़ा सा आइडिया दिया था in our previous class. Because our outer electron is present in the s orbital, that's why we call them s orbital. We call them s elements, या फिर we call them s block elements. That is the main proper word. Okay. Now the best point is, I have already told you that this periodic table has been classified on electronic configuration as well as some properties, है ना? तो हमारा जो first group है, that is lithium to francium, that is known to be alkali metals. That is known to be alkali metals. The reason behind that is most of the compounds are metal in nature. All right. Same as it is for the second group, we call them alkaline earth metal. We call them alkaline earth metal. Now you have understood कि metal तो हमें समझ में आ रहा है कि they have the metallic properties, so we have called them metal. But what is the reason behind alkali and alkaline? Alkali और alkaline नाम क्यों दिया गया है? You know very well, बच्चे, in the lower classes you have studied alkali means basic in nature, है ना? So I have told you that this is the law of our universe, that हमारी जो lithium, sodium, potassium है, they are so much reactive that they cannot stay always in single form, है ना? वो कभी भी अपने आप को pure form में exist नहीं रख सकते. They always would be found in the case of either, I would say, oxides, hydroxide or something. और जितने भी हमारे ये metals हैं, lithium to radium, ये जितने भी हमारे पास है first two groups के, they have the basic properties. और only then we call them alkali metal. और हमारा जो second period है, second group है, that is beryllium to radon. इसके अंदर best point क्या है? They have been found maximum on our earth crust. हमारी जो earth की crust है, हमारी जो earth की first layer है, उसके ऊपर they have been maximum found. So that's why we have called them alkaline earth metals. Clear है यहाँ तक? Now I'm going to our second most important point, that is known to be p block elements. जैसे we have told them s block because they have s electrons, we call them p block because their outer shell have p electrons, है ना? So that's why we call them, and their electronic configuration is from np1, np2, np3, np4, np5 and finally np6. Clear? So these are known to be p block elements. Now आपने ऑब्जर्व किया था कि हमारा जो फर्स्ट ग्रुप था, जो सेकंड ग्रुप था, दे हैव ओनली 1 and 2 आउटसाइड इलेक्ट्रॉन्स. अगर मैं बात करूं ग्रुप 13 की, दे हैव 3 इलेक्ट्रॉन्स बिकॉज s subshell is completely filled, है ना? Same as it is if I'm talking about my 14 group. Suppose I'm taking example of carbon. You know very well carbon का atomic number क्या है? 6. That means 1s2, 2s2, 2p2. बन रही है बात? 1s2, 2s2, 2p2. Okay. तो जो 1s2, 2s2 और 2p2 है, इसका मतलब क्या है, इसके अंदर टोटल वी हैव 4 इलेक्ट्रॉन्स, है ना. सेम एज इट इज, आई एम गोइंग टू 15, दैट मींस ns2 np3 ns2 np4 np5 np6, तो दैट मींस 13 माइनस 10, इतने इलेक्ट्रॉन्स इसके आउटसाइड में हैं. ओके, दैट मींस 3 4 5 6 7 एंड 8. और इसीलिए हमारा जो मॉडर्न, वी नो वेरी वेल कि हमारे जो साइंटिस्ट है, दे ऑलवेज कीप मॉडिफाइंग थिंग्स, है ना. हमने स्टडी किया था कि जो पहले हमारे डिफरेंट डिफरेंट लॉज थे, जो डिफरेंट डिफरेंट पीरियोडिक टेबल थी, लाइक डोबरनेल की ट्राइड या फिर मेंडलीव की, वो हमने मॉडिफाई कर दी. सेम एज इट इज, ये जो मैंने अभी आपको बेसिकली फाइनल प्रॉपर्टी बताई है, दैट मींस द इलेक्ट्रॉन्स प्रेजेंट इन द आउटर मोस्ट ऑर्बिट, दे आर 13 माइनस 10, 14 माइनस 10. सो इसीलिए हम इनको थर्ड ए, थर्ड फोर्थ ए से भी रिप्रेजेंट करते हैं कंपैरेटिव टू 13 14 टू. क्लियर है? आई होप इट वुड बी क्लियर टू यू. So this was the first final point which I have told you. Now they have known to be p block elements. That's I have already told you. एक बात बच्चे आपने ऑब्जर्व की होगी that whenever we go from first period to last period, हमारा जो n है, that quantum number also keep on increasing. मैं फिर से रिपीट कर रही हूँ, whenever we are going from our first period to the final sixth period, our quantum number n also keep on increasing. So if I'm talking about first group, it has 1s1. Sorry, first group तो हमारा हाइड्रोजन एंड हीलियम है ना, 1s1. If I'm talking about the second one, lithium means 2s2, sodium means 3s2, potassium means 4s2, same as it is rubidium 5, cesium 6. बात समझ में आ रही है? The quantum number always keep on increasing with the increasing period, with the increasing number of period. Okay, and this point is very important. We will see in our next topic. Okay, so ये clear हो गया. Now the point is our S block and P block combinedly are known to be main group elements. अगर मैं S block और P block elements को combine कर दूं, जोड़ दूं, तो we have called them the main group elements. We have called them the main group elements. Clear? Now, okay, on the basis of electronic configuration, we have taken two different series, that is group number 17, fluorine, chlorine, bromine, and iodine, same as it is group number 8. I hope it's visible to you. Helium, neon, argon, krypton, xenon, and radon. Okay, so this final, that is group 18, this is known to be noble gases. This is known to be noble gases. और इसके पीछे reason क्या है? The only reason behind this is the electronic configuration, because our group 18, it has complete electronic configuration. That means ns2 and p6. Okay, suppose if I'm talking about helium, if I'm talking about neon, उसके अंदर टोटल 10 होते हैं ना, same as it is 3p6, 4p6, 5p6, 6p6, है ना. So since they have the complete electronic configuration, they are known to be noble gases. Noble means their reactivity is zero. वो किसी के साथ रिएक्ट करना पसंद नहीं करते most of the time. क्यों? क्योंकि उनके पास इलेक्ट्रॉन्स कंप्लीटली फिल्ड है, ना उनका मन है इलेक्ट्रॉन्स डोनेट करने का, ना उनका मन है इलेक्ट्रॉन लेने का, तो why would they react ना? So that's why they are known to be the noble gases. The fluorine, chlorine, bromine, and iodine group 17, this is known to be halogen. इसको हम क्या बोलते हैं? Halogen. Okay, you just keep that in your mind. Now let's move to our next topic. That is the D block. अब D block के ऊपर हम move कर रहे हैं. We have the D block elements. That means n-1 D1, n-1 D2 up to n-1 D10. Okay. In our D block elements, we have the atomic number starting from 21 to 30. That means scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Same as it is from ytterbium to cadmium, from lanthanum to mercury, from actinoids to so on, because they are known to be the radioactive. So on, study later. Okay. These are known to be d block elements क्योंकि उनका outermost जो electron है that is present in d block. Now the question arises why I have put the name n-1 rather than n. The reason behind that is in this case we always have 3d10 4s2 configuration. I hope you have remembered in copper and cobalt. मैंने आपको बताया था कि कॉपर और कोबाल्ट जो है वो हमारे एक्सेप्शन है, बट यू मस्ट हैव रिमेम्बर्ड कि उन केस में वी हैव 3d10 4s2. तो हमारा मैक्सिमम क्वांटम नंबर क्या है 4 और हमारा d किस में इन्वॉल्व हो रहा है 4 - 1 = 3. So that's why I would like to say it. This is 3d10. Oh, sorry. Yeah, this is 3d1 to 3d10 4s2. So this is n-1 d10, but ns2. Okay. Now, okay, the first point is why I have named it the transition series. Why I have put the name transition series. Okay, so the first question I have taken, why I have put the name transition series. The transition means the bridge. Transition means the bridge which connects. So आपको ये ऑब्जर्व हो रहा होगा कि जो ट्रांजिशन सीरीज है, it has combined, it has connected the S block element with the P block element. The S block element, they have been, if I would just remove it, there would be no connection between them, है ना? Because there is so much difference in the atomic number. If I'm talking about my beryllium, it would, I think, hydrogen, helium, lithium, beryllium 4. If I'm talking about boron, it has almost 13. So बीच में we have so much difference, almost 9. तो ये जो 9 to 10 difference है, this was covered up by the scandium to zinc. That is the transition series. That's why they are called to be transition. That means they are connecting. They're like a bridge, okay, between S block and P block elements. Rather than जो हमारे transition series है elements हैं, इनके अंदर we have two different cases, the lanthanum and the actinium. This is called to be lanthanoids and this is called to be actinoids. Lanthanoids we call them because the first element is known to be lanthanum. Second one, the actinium is known to be actinoid series. हमारा जो lanthanum और hafnium है, I would give you the exact term. It has 5772. Yes, our lanthanum, it has Z = 57. और हमारा जो hafnium है, it has Z = 72. So the question arises from 57 to 72. हमारे बीच के elements कहाँ गए? From 57 to 72, where are other elements? Okay, these are known to be inner transition series. Why do we call them inner? Because they are hidden. They are inside the transition series, but they are no transition elements. That's why they are called to be inner transition series. From 57 to 72, we have the lanthanoid series. यानी यहाँ पे lanthanum से पूरी की पूरी एक series है up to 71 atomic number. Okay, same as it is if I would talk about actinoids, they have from actinium to last जितने भी है, suppose this is 112. Okay, so these are known to be lanthanoid as well as actinoid series, the inner transition series, and the best point is they have the electrons in the F subshell. That means n-2 F1 to 14. So they are known to be F block series. Okay. Now you must have remembered कि हमारा जो D block था, उसके अंदर हमारे पास 5 different orbitals थे. So we can fill up total 10 electrons. But our F block element, they have total 7 different orbitals. So 7 to the 14. There are total 14 electrons that can accommodate. That's why they are known to be F from 1 to 14, from 57 to 71. Okay, clear है यहाँ तक? This was all about my complete, I would say, my complete periodic table, in which we have studied S block, D block, P block, and F block, or we can say alkali metal, alkaline earth metal, transition series, inner transition series, and the main group elements. Clear? Noble gas is very important because it has the complete filled electronic configuration. Okay, this was all. Now I'm going to my next topic, that is the exception. We know very well exceptions are everywhere. In our periodic table, there is also an exception. Okay, the first exception is F block, कि हमारे जो lengthenime है और उसके बाद हमने उसको direct have start किया with HF, that is 72. So the question here arises कि what happened and 72, the elements have been inside over there. They have been hidden over there. The reason behind this is they have totally different property. Okay, they have totally different property. So to maintain our periodic table to maintain our periodic table in the form of properties, we have put them on the another level. Okay, that's the first exception. The second exception is my hydrogen and the helium. The hydrogen and the helium. Okay, I would tell about hydrogen and helium, some new point over here. Okay, now the first point is, if I'm talking about my hydrogen, अगर मैं hydrogen की बात करना चाहती हूँ, तो what is the best thing over here? The hydrogen has only one S1. बच्चे अभी जो मैं आपको पॉइंट्स बता रही हूँ ना, और helium, this is the super important topic. Okay, ये exception 110% would come in your exam. So please be concentrated. Okay, first one I'm talking about my hydrogen. The hydrogen has only one atomic number, that is 1s1. So 1s1 के according we should put them in our first group. I hope I'm clear to you. I want to say that hydrogen due to 1s1 should be put in lithium series because it also has the 1s1. But the lithium wali series hai, that is known to be alkali metal. They have the metallic property. But is my hydrogen metallic in nature? Not at all. This is gaseous in nature. Okay, so hydrogen को हम यहाँ पे fit नहीं कर सकते. Now another point is, this is 1s1. It wants to be could be put in our halogen series. Why is it so? क्योंकि halogen के series के अंदर भी हमारे पास NP5 है, तो ये एक इलेक्ट्रॉन लेके नोबल गैस में जाना चाहता है. ये होता है हमारा p block का केस कि this is NP5. If it would accept one electron, it would go into our noble gas, है ना? तो hydrogen, if it would accept one more electron, it would become as helium. Helium के पास completely filled subshell है 1s2, क्योंकि 1s के अंदर तो maximum 3 electrons ही आ सकते हैं. So our hydrogen is behaving somewhat as halogen and somewhat as alkali metal, but properties are totally different. Only on the basis of electronic configuration we can say that. Okay, so इस वजह से we have put our hydrogen not in first group, not in 17 group, we have put it other side. हमने इसको सबसे separate रखा है. This is the first exception. Okay, keep that in your mind, that hydrogen do not come in any kind of group. It doesn't come in any kind of category. Clear? Now, same as it is, if I'm talking about my helium. Helium जो case है, this is also very exception case. कैसे? Same as it is on the basis of our, we can say, electronic configuration, right? If I'm talking by my helium, helium has hydrogen z equals to 1. Helium has z equals to 2. That means 1s2. So 1s2 के according, we should put them into alkaline earth metal. Okay. But in the very same case, they have the same property of noble gas. That means noble gas के अंदर भी electronic configuration is completely filled. The subshell is completely filled. Same as it is my s orbital, that is also completely filled. Okay, so ये completely filled है, तो ना हम इसको यहाँ पे रखना चाह रहे हैं, but जो इसकी noble gases से ज़्यादा मैच होगी. Helium gas भी है, and most obviously इसकी बहुत सारी properties हैं, they match with the noble gas that we would see in our next class. Okay, so that's why we had put our helium in 18th group rather than the second group. Okay, so this was the whole case about my periodic law. Now we have been left with only last topic, that is classification on the basis of their metallic nature. The classification on the basis of their metallic nature. Let's see this last topic and we would then wrap up the complete periodic table. Okay. Now, I would like to say the metallic nature. Most of our elements in complete periodic law, complete periodic table are metallic in nature. They are metals. Okay. First of all, I have cleared about alkali and alkaline earth. Second point, if I would talk about my transition series, मेरे जो complete D block elements हैं, they all are metallic in nature. They all are metals. Okay. If I'm talking about scandium, titanium, vanadium, जितने भी हैं, they all are metal. But exception is my Hg, that is mercury. You have studied, you have understood in, I think, the 9th class that our mercury is only metal which is liquid at room temperature. Okay, solid का nature क्या होता है? That they have been completely, fixed electronic composition. They are completely, their intermolecular force of attraction is negligible. है ना? Sorry, not negligible, very strong. Okay, so these are metals. These are metals. Mercury is somewhat which is liquid in room temperature. इसके अलावा my zinc, cadmium, they are also very, very soft metals. Okay, so the question arises, what's the case in these three kind of like elements, zinc, cadmium and mercury? इन तीनों में ऐसा क्या नया है कि कोई हमारा लिक्विड है, कोई हमारा सुपर सॉफ्ट है ना? The reason is also electronic configuration. According to the electronic configuration, my zinc, cadmium and mercury, it has the complete D10 subshell. है ना? It has 3D10, it has 4D10 and it has 5D10. Due to complete filled D subshell, they are very soft in nature, or either we can say our mercury is liquid at room temperature. Okay, clear? So I have told about the metals first of all. Now I'm going to talk by my non-metals. Okay, I hope you know very well कि हमारी जो metals होते हैं, they have the properties totally different from the non-metals. Like metal are hard, they are solid, they are ductile and malleable in nature. You know ductile and malleable? Malleable means they can be beaten into thin sheet, and ductile means they can be beaten into long wire. You know that. Whereas my known metals, they are boron, carbon, nitrogen, phosphorus, selenium, iodine, fluorine, chlorine. They all are non-metals, first of all, from boron to iodine. They all are non-metals, which I have put in the blue shape. Okay. And the second most important point is they are almost gaseous in nature. The only exception is bromine. हमारा जो ब्रोमीन है that is liquid at room temperature, just like mercury. Okay, इसके पीछे कोई reason नहीं है, basically कोई electronic configuration. It has just its own physical property that it is liquid at room temperature. Okay, now these are the metals, these are the non-metals. We have another series that is known to be metalloid. Metalloid किसको बोलते हैं? Which have intermediate property of non-metal. कुछ प्रॉपर्टीज जो है मेटल की हैं, कुछ प्रॉपर्टीज जो है नॉन मेटल. दे आर नोन टू बी मेटेलॉइड्स. और जो हमारे मेटेलॉइड्स हैं, दे आल्सो हैव बीन पुट इन जिगजैग सीरीज. ये हमारा जो जिगजैग शो हुआ है ना, इसको हम बोलते हैं मेटेलॉइड्स. यू मस्ट कीप दैट इन योर माइंड. योर सिलिकॉन इज द मोस्ट अबंडेंट मेटेलॉइड ऑन योर अर्थ क्रस्ट. डेफिनेटली सिलिकॉन जो है जिससे हमारा रेत बनता है, दैट इज द मोस्ट अबंडेंट metalloid in your earth crust. Okay, silicon, germanium, antimony, arsenic, tellurium and polonium. These are the 1 2 3 4 5 6 elements that you must keep in your mind that they are metalloids in it. Okay, now I have been left with the super last topic, that is the number of elements. The question arises that each different period has different number of elements within them. कैसे? If I would talk about my first period, अगर मैं हाइड्रोजन को फर्स्ट पीरियड में पुट कर रही हूँ, तो हाइड्रोजन एंड हीलियम फर्स्ट पीरियड में सिर्फ 2 एलिमेंट्स हैं. If I am talking by my second and third, they have the total 8 elements. 1 2 3 4 5 6 7 8. Same as it is 1 2 3 4 5 6 7 8. So 2 8 8 2 8 8. I hope this is clear to you. Same as it is if I would talk about my first, second, third, fourth and fifth period, they have total 18 elements. क्यों? क्योंकि उसके अंदर हमारी transition metal भी हमने include कर दिया है. Transition metals have been included, so the number of elements also have been increased from 8 to 18. D1 to D10, total 10 elements we have added. So 2, 8, 8, 18, 18. And the finally we have 32, 32. ये question आएगा बच्चे in MCQs. So please keep remembering in your mind that which particular period has 32 elements. So I would say the lanthanum and the actinoid series. Why? क्योंकि lanthanum actinoid में we have hidden elements. Okay, so they have 32 elements rather than 18 18. Okay, so 2 8 8 18 18 32 30. All right, this was all about my topic that is known to be periodic table. Clear hai? Now I would just want to say that in our next class we would study the trends. That means अभी हमने जो study किया है, अब हमें उनकी properties को group wise, period wise study करना है. Okay, that is known to be trends. That is increasing order, decreasing order, ascending order, descending order. That is means trends. So our next topic would be trend that we would study in our next class. Okay. So class, this was all about by my side. Now, if there is any kind of doubt or query, please ask.